Hi everyone. Okay, let's have a quick read of this question. Two small blocks A and B are connected by light and extensible string. B lie above A on a line graded slope rough plane, inclined at 30 degrees, so it's rough. Block A has a mass of 2.5 kg, block B has a mass of 1.5 kg. It's connected by a 1 meter long string, and block A begins 2 meters above the foot. The coefficient of friction between each block has and the surface is 0.15. So really, there's a couple of ways of doing this actually. The system is released from rest, t equals 0. When block A reaches a foot of the slope, its slope stops immediately. Its motion stops immediately. Find the time at which B collides with A. B collides with A. Okay, so what I'm going to do is I'm going to treat this, because as this is coming down, that's the tension holding that back, and then that's going down. But given that the coefficient friction is the same for both of them, I'm going to combine these two and treat them as a total mass of 4 kg. Okay, and see how long it takes for A to reach the floor. Okay, so first of all, Suvat, because that's what we're going to do. Right. Well, before we do Suvat, let's just combine this as a particle. This will come down, the combination, this will come down, coming that way, and that's the contact force here. So this is a combination of A and B, so that's going to be, the weight is going to be 4g, so that's going to be 4g cos 30 degrees and 4g sine 30 degrees going that way. Okay, down the slope. Okay, so also remember that friction is mu times contact force. Okay, in this case mu is equal to 0.15. Yeah, so we got that. Okay, now let's just double check which way that's going down. Yep, if it's coming down, friction is opposing it. Let's just double check the friction. So what is the friction? Friction is equal to 0.15 times yep, the contact force is 4g cos 30. So that's going to give me 0.15 times 4 times 9.8 times cos 30. I'm going to get 5.09. I'm going to do it 2102 newtons opposing it. Okay, so that's friction going that way. As that's coming down. So yeah, so let's look at the force coming down. Force equals mass times acceleration. So that's coming down with 4g sine 30. Opposing it in motion is friction, 5.092, and that is equal to total mass 4 times acceleration. Divide that by 4, therefore acceleration in this case will be, so look, 4 times 9.8 times sine 30, subtract 5.092, and then divide that by 4. We'll get acceleration to be 3.627. Okay, so that's acceleration of those coming down. So Savat, we can use Savat as it's just constant force. So SUVAT is released at time equals 0. So acceleration is, that's going to be 2 meters, and that's going to be so that's going to be 3.627. It's released from rest, system's released from rest, so initial is 0. And what do I need to find? I want to find the time it will take for this block A to hit the floor. So I want that, and that. No V. Okay, so we can use the equation S equals ut plus half at squared. So that is 2. That's going to be 0. So that's going to be a half times. So let's just do that in the calculator. Half times the acceleration 3.627. That's going to be 1.8135 t squared. Therefore, divide that through by 2 divided by 1.2. So that's going to give me t squared. Once I divide that through, it's going to give me 1.1028, and if I square root that, that'll give me 1.0502 seconds. So that's the timing it will take when A hits the ground. Okay, now when A hits the ground, right, I treated that as one combination because it was connected by this. Okay, so this was the tension grabbing that. Okay, that was holding it back, sorry, this tension. So that's why I treated it as a single, and because also the same had the same coefficient friction, so could have just lumped them together. That's why I treated that and brought them along. Okay, that's the reason. Now we know that A has reached the ground, so when A reaches the ground, that tension no longer exists. So B is by itself, and there's only 1 meter, so we need to find now how long it will take for B to travel 1 meter before it collides, and then we get the total collision time between B and A. Okay, which we then add on together. So first of all, I know what I could do here, as that's come down, because they're both moving in the same motion, I could work out the final velocity here too. Okay, so I could have got that, so that would give me the initial velocity at which B is moving at. So let's just quickly do that. Easiest way to do that, final velocity, yeah, let's just do it this way. V equals u plus at. I know that's the time it needs to travel at, so V equals 0 plus 1.05 times acceleration 3.627. So my final velocity from there, so multiplying that by acceleration 3.627. So my final velocity is going to be 3.81 meters per second. Okay, so I'm just going to put that there, 3.81. So that's what it's going to be traveling at. B is going to be traveling at that speed. So let's put what we got information. I want to now know again, so that is UVAT. Now the distance I want to travel is 1 meter. My initial speed at that point is 3.81. I need to find what the time is, and I need to go back and work out what my acceleration will be traveling. So my acceleration has probably changed because of the mass. I'm just going to double check that. I might not have, but I'm just going to double check, see if my acceleration, what is my acceleration. So if I just concentrate on the B particle, that's just going to be coming down. So that's going to be, the weight of that is going to be 1.5 g multiplied by sine 30. So that's what that's coming down as, 1.5 g sine 30. And opposing it is friction, which is going to be 0.15. Just hide this a bit. 0.15 cos 0.5 times 1.5 g cos 30, and that's going to equal to the mass of that 1.5 times a. So I'm going to work that out, then divide it by 1.5 to get the acceleration, to see if it's any different. So if I do 1.5 times 9.8 times sine 30 minus 0.15 times 1.5 times 9.8 times cos 30, that'll give me 5.440 etc. equals 1.5a. Then divide that by 1.5, which will give me a equals divided by 1.5. So acceleration has changed to 3.6 now, to 3 single figure 63. I've got 3.6269, so I'm going to call it 3.63. Okay, and I just need to find the time now. So again, I've got SUAT. So yeah, let's put it in our formula. You probably need your calculator here. So you've got 1 equals UT. So I'm using this one again. Just put that, just saving time and space. So 1 equals initial speed is 3.81 times t. Then it's a half times the acceleration, so times 0.5. It's going to be plus 1.81 t squared. So if I put that in my, I'm going to just use my calculator and use it as a polynomial. So shift it into the mode. Polynomial degree 2. Okay, so I'm going to use a as 1.81. Sorry, for my quadratic, the coefficient of x squared is 1.81 plus, sorry, then for b it's going to be 3.81, and c is going to be minus 1. I'm going to bring the 1 over. So I've got t is equal to 0.236, and the other one is a negative, so I'm going to ignore that. The other one was t equals minus 2.34. We ignore negative time. So we've got, this is the time, and then this time. So when it goes here, system is released from rest. When block A reaches a fault, its motion immediately stops. Find the time B at which B collides A. find the time at which B collides A. So first of all, it's in motion for that, so find the time at which B collides A. So total time of collision will be 1.0502, which is this time when block A reaches the floor, plus 0.236, the time it takes for this to travel. So if we add those together, 1.0502 plus 0.236 would take, to freeze from the figures, 1.29 seconds for B to collide with A. Okay, so basically what's happened here is we computed, because they had the same coefficient friction, we treated them as one block coming down, but as soon as A reached the bottom, that tension was broken, and therefore B was traveling independently, and therefore we had to recalculate the acceleration at which B was traveling at, okay, without having this string attached to it. So first of all, it took 1.05 seconds for A to travel to hit the floor, and then when we recalculated the status of B, and we also worked at the final velocity, which became initial velocity at what B was traveling, to use to that, and then we worked it out from for our calculator, and found out that it would take 0.236 seconds for B to collide with A. So in total time for B to collide with A will be the 1.05 plus the 0.236. So that gives you a total time of 1.29 seconds that it will take B to collide with A. Okay.